Good day, everyone. In this video, we are solving polynomial equations. Alright, let's go ahead and talk about this definition. And you're going to keep seeing it because sooner or later, before the 9 weeks has ended, you will have to know this definition. There's going to be an activity that you may have to do to help you prepare for it. The precise definition of mathematics is the technique to explain, understand, and manage reality specifically by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. Now, in the previous video, when we was factoring in by cases, I gave you a beautiful example of how I model patterns arising in the environment. And the example I gave you guys was studying, preparing for a test. I hope you guys recall this because you're going to probably be asked about that at some point. So you may want to replay the video if you have not done so you can know the example of what I use to describe the modern patterns arising in the environment. Alright, let's move on. Math is mistakes allow thinking to happen. Alright, the concern that I have with guys with this is that we have not quite grasped the situation, but when the grades decrease, you'll find out. All I'm telling you is I need for you guys to grow from what you have done with me day one. Mistakes allow thinking to happen. That means you're really trying. You're really putting those effort in there. And that is how I know that you are doing mathematics or math is for every problem that I give you, I see that bill for work. Work that's not from Photomath, Mathway, or any crazy website like that. It comes from you. Alright? Now, on my test or quiz, I may ask you so I can know if you cheat or not, to demonstrate the skill exactly as how I taught you. Not you going from someone else. I'll explain that in more detail. Alright. Let's review. Let's bring you back to some geometry. And this is a good ACT review as well because you're going to be required to know this. What is this? We know this as the Pythagorean theorem. So let's go for it. We know the formula, and this is on the ACT. You will not have a formula sheet. You're going to have to know how to do this by hand. A squared plus b squared equals c squared. Alright. 12 squared plus b squared equals 13 squared. Alright. So we know 12 squared is 144 plus b squared equals 169. I know when I get b by itself, or x that is, but you know, I say x to be b. So I want you guys to understand then when I'm saying b, I mean x. So let me rewrite this as b. You could use x if you want to, but I prefer b because a squared plus b squared equals c squared. That's how I remember things. All right, so let's finish this up. B squared equals 169 minus 144. And when we subtract that, we get 25. B squared equals 25. Now, I don't have any more space at the moment, so I'm going to erase. B squared equals 25. So let's take the square root. Square root. So when you take the square root, you get 25, and we know the square root of 25 is 5. So b equals 5. But since I use x instead, I use b instead of x, you could say x is 5 if you want to. And remember, I use the little dots. This is how I indicate my final answer. Now again, you may be asked on the test to replicate what was taught to you from me. Alright? But this right here, this is just geometry, ACT stuff. So again, you won't have a formula sheet in the ACT, so it'd be best for you to know how to do this. Alright, let's move on. Alright, so let's review. We've been talking about polynomials for a hot minute now. So let's go over it again. The definition of a polynomial function is let n be a non-negative integer and let a of n1 through a1, a2, a0 be real numbers with an not equals 0. The function defined f of x anxn is called a polynomial function of a degree n. Alright, and number an, the coefficient of the variable with the highest power, is called the leading coefficient. So long story short, as I told you guys in previous videos, a polynomial function is basically a function y equals where they have an exponent of 0, which this is called a constant. Anything to the power of 0 is called a constant. x1, x2, x3, x to some very huge number. So as long as your exponent and the function have all that going on and no negative numbers, as the definition says, guess what? You got a polynomial function. Here's a final example of a polynomial function. Why is this a polynomial function? As I told you, you must look at your exponents. You got x to the power of 5. Although you have a square root here, but it's not under any x. Then you have x squared too. So those exponents are greater than or equal to 0. But they're greater than 0, so therefore it is a polynomial function. Alright, types of numbers. I talked to you guys about this before. If not, which I doubt, let's go ahead and go through it anyway. Y'all, what's an integer? Integers are -1, 0, 1, 2, 99, 99, if you want to go there. So how do you represent an integer? We use the symbol z. Now, if z has a plus, we know it's positive integer. If z is negative, we know it's a negative. Rational numbers, what letter do I represent that with? Q. Q for quotient. So that means that I have to have two integers that are a quotient, or in elementary terms, a fraction. 1/2, 1/3, -1/5, and 1/7, and 2. 9, it could be any of that. Again, rational numbers could be positive, or they could be negative. So let's talk about real numbers. What does it mean to be real? Well, a real number, if you want to go there, could be pi from your geometry class. It could be also a rational number, and it can be an integer. So a real number could be rational and an integer, but an integer. No, let me be careful. So a real number can be rational and an integer. A rational number are two integers. Alright? Complex numbers. We're going to talk about that later on today. Some of you guys already know a complex, some of you guys do not. But it's okay. Alright, let's proceed. Alright, so guys, these problems look mighty familiar. We've been working on these. So let's look at the first one. So if I was to say the word factor, and this is factoring what? A binomial. What does 1624 have coming again? Greatest common factor? 4. And the I side, what's going to be left on the inside? X minus 6. That's how you factor that. Okay, so what about the second problem? This guy. What do they have in common? They do have a 4, but also they have an X in common as well. So what's going to be left on the inside? X minus 2. Alright? So let's talk about the last one. What is the greatest common factor that this has? Well, they have a 9 in common, but they also have a x squared in common. So I pull that out. What am I left with? So if I took 2 from 4, I'm left with x squared. If I took 2 from 3, I'm left with a x. If I took 2 from 2, I have nothing. So now I did my variables. Now let's do the coefficients. So if I pull out a 9, from 9 I just have 1 or x squared. But if I took out 9 from the 18, Now, I'm not doing subtraction, I'm just using my factors. Negative 2x. So, but if I pull out a 9 from 27, I get 3. Alright? Again, this is just review what we are doing. Nothing new. We've been talking about it. Alright. So let's review the factoring cases we have been doing. So, problem 1. Let me address this right quick. This is not a decimal. This is not a decimal. That is not a decimal. I want you guys to get that again. Not a decimal. So with that being said, let's go ahead and solve this problem. Which case is this if I was to ask you to factor? Case 1, factor by grouping. Alright, so when I'm factoring by grouping, I know for a fact that the binomial that I had in the first parentheses, it has an x squared in the common, so I'll pull that out. And what I'm left with that first one, x minus 3. Okay, so I know if I have x minus 3 in that parentheses, I know when I do it again to the second one, I should have x minus 3 for the answer again. So 4x minus 12, if I was to pull out the greatest common factor, which is 3, or 4 in this case, I get x minus 3. What am I left with when I finally write this final answer? X squared minus 4 and x minus 3. That's my final answer. And that was case 1. So let's look at case number 2. That problem is case number 2. Alright, I know I haven't gave it the proper name for it, but you may not need to have to worry about that. But you know case 2, you know what you have to do with case 2. What two numbers multiplied together gives me my 45? I could use 9 times 5, but remember, I got a negative. So that means I'm going to have two negative numbers multiplied together gives me my positive 45. So that's going to be negative 9 times negative 5, which is 45. And we know that negative 9 plus negative 5 is negative 14. So we know that. So guess what? Let's factor it. Put it in factor form. X minus 9, x minus 5. Again, those dots, just let you know, hey, that's my final answer. I'm done. Alright, let's move on. Alright, so those look similar. So let's identify which cases are these going to be. This is going to be which case? The problem to the left. And how we know? Well, say we don't know. Let's look at the second one, the problem to the right. We know this because 49 is a perfect square. This is going to be case 4, dealing with squares. So we know 49 is going to be 7. But remember, we know that we got a negative in the center. Because we have negative in the center and positive in the back, we are going to have x minus 7 and x minus 7. And that's it. Or you could rewrite it as x minus 7 squared. This is just another way of doing that. Alright? So, to check your work, as I have tell you, I'm not going to do it in this video, but I'll show you how. Just use your for the method. Use your for the method. I'm just going to set it up for you. X times x. X times negative 7. Negative 7 times x. And negative 7 times negative 7. When you do that, you get x squared minus 14x plus 49. And that's just the for the method. I didn't do it all the way because I kind of felt like, hey, I don't have the space to do the other problem. But this is just showing you on your test, you will have to be able to know how to quickly solve it and show your work. Alright, so we know that was case 4. Let's do case 3, Mr. Howard's favorite method, which is the swing method. Now, clean this up. Alright, let's proceed. I'm over here doing this problem. This is the swing method. So we know we have to multiply A times C, the front times the back. So 8 times 4 is 32. So you're going to rewrite it. Sorry, y'all. S squared plus 33 plus 32. Alright. So we know, similar to case 2, we know we got to find numbers multiplied together to give me that 32. But then you got to add them. They got to give you 33. So 32 times 1 does give you 32. But 32 plus 1 gives me 33. So that's going to be x plus 32. X plus 1. Alright, now you gotta divide by your original A you started out with, which in this case is going to be 8. 32 divided by 8, 1 divided by 8. So 32 divided by 8, do I get an integer? Yes. 32 divided by 8 is 4. So x plus 4. Alright. So 1 divided by 8, do I get an integer or do I have to do what? Well, I don't get an integer when I divide 1 into 8, so I gotta swing that 8. Swing it. And guess what? That is your final answer. You are finished with the swing method. Alright? This problem, this is the infamous squares and stuff method. But guess what? It's pretty separated already. So with the squares and stuff, if you got something that looks, a problem that looks like this, you could group that in a trinomial because they got stuff to work with, and 25 is a square. So we know that 25 is a perfect square, and we know when we add 5 into 5, we get 10, but in this case, it's going to be negative 10. Just like how you did case 2, you're just going to factor it as you did before. So you know what two numbers, when you multiply together, gives you that 25. And then those same two numbers, add, gotta give you that negative 10. Now, I already taught you my third little secret. This is negative. This is positive. So that means two negatives, which we know is negative 5, and negative 5 gives me negative 10 when I add them. But when I multiply them together, negative 5 times negative 5, I get a positive 25. So in this case, you should get x minus 5, x minus 5, or x minus 5 squared. Now, let's do something about this 36y squared. This is what you're going to do. We know that 36 is a perfect square. And because it's minus 36, you're going to do 6y squared, but it is best for you to put it in parentheses. That's what you're going to do. Put it in parentheses. And because it's minus, you're going to put it like that. Now you erase this so it could look like an arrow. And that's how you solve that problem. Just like that. Now, I think I told you that you don't have to complete it all the way, but I gave you a bonus, but I want you guys to do this anyway. Even if it's bonus, you're still going to do it. Just like that. And I'm cool with that, y'all. I'm cool with that. Alright. Let's move on. Alright. Solving equations, two methods. Factors versus square root. Alright. So look. I have told you guys this. That when I'm dealing with square root could be rewritten as x to a half power. So I told you guys that. But I also told you that when you're dealing with the quadratic, its inverse or reciprocal is going to be x to 1/2 because 2 is the multiplicative inverse of 1/2. They're inverses of each other. Now, you're going to see why this information I just gave you is important and relevant to what we're doing today. Alright, let's go ahead. Alright, let's solve a quadratic equation by factor. So, we know what quadratic factor look like. Those are those trinomials that you've been working on in case 2, 3, 4. Alright, so let's do it. Here's a quadratic, also known as a trinomial. We know when we find numbers, well, when we group everything, put everything in coefficients, so therefore our work could be easy. Alright, so we know A is 1, because any variable that don't have a number attached is always with 1. B is -7, and C is 10. So when we get ready to factor this, you're going to factor this like usual. Those are the numbers when you multiply together, you're going to get positive 10, but when you add them together, you're going to get -7. Alright? And of course, if you're struggling to believe that, just do your little for method. Find out. All right, let's proceed. So look, let me explain what was done here. So each factor, like this x minus 5 and this x minus 2, are both set to 0. You want to set them to 0 just like that. Alright, so let's look at x minus 5. Again, you're going to set it to 0. And the reason why you do that because you're trying to solve the equation. And these types of equations, you're always going to say equals 0. Always, always, always. So, getting back to it. So when you move 5 to the other side, you get x equals 5. Alright, that's one answer. Alright, so x minus 2. When you move that to the other side, you get x equals positive 2. Now, you notice that we end up with how many answers? 2 of them. Any ideas why? Your leading exponent. Your leading exponent tells you how many solutions that we have. Now, alright, let's get back to this. Again, because you see x squared in the front, that's going to tell you you're going to have 2 solutions. Solutions is another word of saying 0. And I explained that definition of 0 a little bit further. Alright. So, this is called the zero product principle, the method of solving this equation by factor. If the product of 2 algebraic expressions is 0, which is this guy right here, then at least one of these factors is going to be equal to 0. So basically, we set them both to 0. Again, this is called the zero product principle. Something that you may want to know. So, which of the 5 cases will you solve by using the zero product principle? Well, we figured this out already. We know case 2, 3, and 4 are going to use that situation. Alright. So let's do it. So you've seen this before. We know when we factor, we're going to get x minus 9 and then x minus 5. Now, those are the factors, so let's set them both to 0. Starting out with x minus 9. X minus 9 equals 0, but when you add 9 to both sides, you get x equals 9 for one of those solutions. Alright, so let's do the x minus 5. X minus 5 equals 0, but if I add 5 to it, x equals 5. That's 2 solutions. And they're using the zero product principle. And we did this with case 2. Alright. Case 3, again, we did these problems already. But, I just want you guys to see how the stuff that you've been doing, how it builds up. Alright. Just like when you do your factoring, since we did this before, we know our factoring of this is going to be x plus 4, and then 8x plus 1. Alright, that was our factor form of this. Now, let's use the zero product principle. X plus 4 equals 0. When I subtract 4 from both sides, x equals negative 4. So let's do ax minus 1. 8x, well, plus 1, equals 0. Subtract 1 from both sides. Subtract 1 from both sides. Then you get 8x equals negative 1. And then x equals negative 1/8. And we just did this, the zero product principle. Now we're done. And we did this in case 3 swing method. Alright. And now I'm supposed to show you case how it works in case 4, but if you've seen it in case 2 and 3, 4 is no different. It's just you're dealing with squares, that is. The square root property. So look, because we are mainly dealing with the quadratic, we know that it's always going to have two solutions. Now, because remember what I told you about x squared being the inverse of the square root of x. So you know when we solve problems, solve equations, you know you're dealing with pluses, which is the inverse of minus, multiplication, which is the inverse of division. You know those things. Alright? So, let's talk about the square root property. Now, since I showed you guys all this, it said if u is an algebraic expression and d is a non-zero real number, then u squared equals d has exactly two solutions. So it's either going to have a positive d or it's going to have a negative d. So you're going to have plus and minus always. So look, do me a favor. Get a calculator. Let it be your phone. Let it be anything. Try to put the square root of negative 5 in your calculator. If you did this correctly, you will get an error message in your calculator. My B-Day students did imaginary numbers. So guys, the reason why you get an error on this because this is not real. Any negative number in the square root is not real. It does not exist. It is imaginary. So again, anything that's negative in the square root, like negative 1 or negative 9, imaginary. You're going to get an error message every time. If you do get a message, you yourself did something wrong, you will get an error message every time. Alright? So, my A-Day students, I know we touched on this briefly, but we're going to spend some time going over it. B-Day, you know what's up. So guys, anytime you have a negative number, like I know I didn't cover this in neither A or B day. So you got -3. That negative sign, you pull that out, it becomes I. So I, then the square root of 3. So basically, what I'm telling you is that any negative, like -1, that negative sign is just saying for you to use I and square root of 1, which we know square root of 1 is simply just 1. And you can use I, 1I, or just I. So again, you can't have negative numbers in the square root because it's imaginary. And you're going to always have 2 answers. Alright, let's move on. So which of the 5 cases will you solve using the square root property? Case 1, mainly. So guys, when we solving equations, case 5 is, you won't be using case 5, period. You want to use only cases 1 through 4 for either the zero product principle or the square root property. So in case 1, it's going to be the square root property. And let me show you why. So we factored this before. We know we're going to get x square plus 3. And we know we're going to get x. Well, I'm sorry, it's not plus 3, it was 4. I'm tripping. X plus 4, then x minus 3. That was the answer that we had when we was working this. Now, this does look similar to the zero product principle, but I guarantee you it's not going to happen like that. So, let's go ahead and do this. X squared minus 4 equals 0. I mean plus 4 equals 0. So, subtract 4 on both sides. The inverse of this of square is going to be square root. It's going to be x equals the square root of -4. So you put this in your calculator, you know for a fact that that is not allowed. You're going to get an error message, so don't you dare think, Mr. Howard, my calculator broke. No, it's telling you you cannot do that, so don't try to do it. Alright, so let's break this down. We know that the square root of 4 is 2, right? Don't forget you have that I to contend with, so you go bring I out because of the negative sign. So your final answer should be x equals, because you're dealing with the quadratic, you're going to have plus and minus 2i. Now this x3, x minus 3, we just solve like we did. F minus 3 equals 0. Add 3 to both sides. X equals 3. And you just did it. Again, I use plus and minus 2i, that's the same as 2i minus 2i. I just don't want to do that. So yeah, those x's are my answers. All right. We are finished with that example. So let's proceed. All right, we got some more examples using the square root property. So let's do k. K squared equals 16. Remember, to solve this problem, you gotta take the inverse of square, which is square root. Take the square root of both sides. So the square root of 16 is 4. And k just becomes k because, again, 1/2 is the multiplicative inverse of 2. And so when that goes away, that just becomes 1. All right. Let's do the square root of 144. All right. 2. Please, you try to get n by itself, divided by 2. All right. Ooh, I'm sorry. So when I divide that, negative 144 by 2, I get 72, which is negative n squared equals negative 72. Let me rewrite that. That's sloppy, even for my standards, y'all. N squared equals negative 72. So square both sides. You get n equals negative 72. Again, put it in carefully in a calculator, you will get an error message. So to rewrite this, you know that negative sign in front of the 72? Guess what? You're going to pull it out. And you could do 72 like this. I'm okay with this. N equals plus or minus I square root 72. That's cool with me. I'm down with that. That is fine. All right. Now listen up, y'all, before I let you go. You're going to have some examples when you do these problems are going to be very similar to the factoring case studies. So cases 1 through 4, you may see again the factor. Now, you may have a different case. All right? You may have something that looks like this. X plus 2 squared equals 1. Now, when it looks like that, you gotta think what to do with that. So how would we handle that, y'all? Well, for starters, you could do the following. Why don't you take the square root of both sides already? And that's going to make things a little easier for you. All right, so let's do it. So when we do that, take the square root of both sides. this becomes x plus 2. And we know the square root of 1 is just 1. Now, remember I told you that quadratics have two solutions? And since that square root of 1 is positive, you ain't going to deal with no imaginary numbers. Alright? So let's go ahead and do this one. So let's solve this equation we got. So if I subtract 2 on both sides, I get x equals -1. Now don't forget, you're going to have two solutions, not one, but two, because the exponent is 2. Because you have an exponent of 2, you're going to have two answers to contend with. So we did one of them. The other one, because you're doing plus or minus, you're going to have x minus 2 but x plus 2, I'm sorry, equals your -1, your square root, because it was positive. That's going to, change. One of them going to be a positive 1, and the other one's going to be a -1. So now with that being said, we can proceed. Don't forget, your square root, because it's positive, you're going to have because the square root inside is positive, you're going to have one positive and one negative. So getting back to this equation, subtract 2 on both sides. When you subtract 2 on both sides, you get x equals -3. And those are those two solutions you need. Alright? So it's going to look just like that. Alright? So I do want to show you one more thing, and then we could call it quits. So what if I give you something that is already in factor form? X minus 4, x minus 4. So, because it's already in factor form, just do this. X minus 4 equals 0. X minus 4 equals 0. And your answer is going to be x equals 4, x equals 4, or we should just say 4 in this case. Alright? That's that situation. But what if you have to solve an equation by a greatest common factor? So remember these kind of problems? x3 minus x square. So this has a 3x, then this has a 6. Okay, so let's factor this. So we factor this, by the greatest common factor, we're going to have a 3x square equals x minus 2. Alright? So because I rewrote this in a factor form, because I wrote it in a factor form, I'm going to have two solutions. So, or 0, so 3x squared equals 0 right here, and then x minus 2 equals 0. So when I solve these equations, the problem on the left is going to be, if we do it, divide 3 on both sides, 3 on both sides, and then we square root both sides, we get x equals 0, because 0 divided by any number is just 0. Alright? So x minus 2 I add 2 to both sides, I get x equals 2. And that's how you solve those problems. Just like that, solve those equations. Now again, you're going to have to show some good work. Alright, y'all. I'm good. I'm logging off.